Chemical basis of life. So basic chemistry, we have matter, weight, and mass. What's the difference? Matter is anything that occupies space and has mass. Mass is the amount of matter on an object, and weight is due to the gravitational force acting on an object. So if you compare yourself on Earth to when you were, let's say you could go to the moon, would your mass change?
Yes.
No, your mass does not change. Does your weight change? Yes. You would weigh more on Earth than on the moon because the gravitational pull is higher on the Earth. Elements and atoms. An element is the simplest type of matter with unique chemical properties, and it composed of several atoms of just the same kind. And that kind is determined on the number of protons. The number of protons determine what element it is. Whereas an atom is the smallest particle of an element that has chemical characteristics of that element. So you have one atom of an element. I thought this chart was actually pretty interesting where it shows the percentage based on weight of each of the elements in your body. So here, the highest by weight is oxygen. If you think of your body is made up of a lot of water, and the heaviest part of water is the oxygen portion, so that makes sense. Carbon, 18%, and then hydrogen, and then it drops off pretty quickly, but that was kind of interesting. And I don't know why there's this little thing there, but. Atomic structure. So atoms are composed of subatomic particles, and they're neutrons, protons, and electrons. Neutrons are neutral. Where are neutrons located? Neutrons?
Oh, in the nucleus.
In the nucleus, yes. Protons are positive, and they're in the nucleus, and electrons are negative, and where are they found? Around the nucleus. And here at the bottom it says most of the volume of the atom is occupied by electrons. Electrons are the tiniest element, or tiniest subatomic particle. So even though it's talking about volume, so these little tiny particles are able to fill up this volume. Most of that volume is empty space, and with these little particles in it. So it's talking about the volume of the atom. Most of the volume is made up of the electrons, where the electrons are located. And that nucleus is really tiny in the middle. Atomic number versus mass number. Atomic numbers are equal to the number of protons in each atom, which is equal to the number of electrons. In an atom, when we're talking about atoms, they're neutral. If it's not neutral, we'll call them ions. So atoms are neutral, so positives have to equal the negatives to make it neutral. The number of protons is what gives, that's how we can tell if it's a carbon atom versus an oxygen atom. It's the number of protons in that atom. Mass number is the number of protons plus the number of neutrons. That number is not on the periodic table. You're just adding protons plus neutrons. Because each isotope will have a different mass number, because isotopes are two or more forms of the same element with different numbers of neutrons, right? Same number of protons, different number of neutrons. So their mass number is going to be different. Their atomic numbers will be the same. Their mass number will be different. So for example, there's the 3 types of hydrogen. Still just 1 proton in the nucleus, but there's 0, 1, and 2 neutrons. Then the atomic mass is the weighted average of all those isotopes. And that's the mass you'll find on the periodic table. The mass on the periodic table is taking into account, there might be 3 or 4 different isotopes with that. Radioactive? Oh, this last period. There you go. There's forms of atoms that emit radioactivity in forms of gamma rays, which then can be measured. Can be used clinically to treat symptoms or in research. So examples would be tracking hormone uptake. They can have trace amounts of the hormone, make them radioactive so they can track where they're going in the body. Treating cancer. You can use the radiation that's produced to treat cancer. Yep, through chemotherapy, radiation. Yep. And then sterilization of materials that are used in surgery. You can use some radioactive isotopes. Bonding. There's a difference between intramolecular and intermolecular we'll look at. Intramolecular bonding is within the molecule. So you're looking at this compound, and they're the actual bonds that are holding that compound together. And there's ionic bonding and covalent bonding. Ionic bonding is atoms exchange electrons. So one atom takes electrons from another, and then they're attracted together. Covalent bonding is when these two atoms share electron pairs. An ion is when the atom loses or gains electrons, it becomes charged, and it is either positively charged, which is called a cation, or negatively charged, which is an anion. So cations, the way I remember that they're positive is the cation has a T that looks like a plus in it. So cation is positive, anion is negative. In an ionic bond, cations and anions are attracted to each other. So one atom would take an electron from another. Once it takes that electron away, the atom that is left is a cation because it lost an electron, it becomes positively charged. The atom that took the electron now has extra electrons and it becomes negatively charged. It's an anion. And now, because there's a positive and negative, just like a magnet, they stick together. That's how an ionic bond forms. It just sticks together because of an electrostatic attraction. Here's some important ions and their significance. You see calcium is part of the bones and teeth, muscle contractions. Sodium's membrane potentials, and membrane potentials can affect muscle contractions. So sodium and potassium, so when you sweat, you're losing some of those electrolytes. So when you drink Gatorade, it's supposed to replace your electrolytes, just replace electrolytes. Yeah. The bad thing about Gatorade is how much sugar. There's a lot of sugar in Gatorade. So, so really, unless you're doing heavy activity, Gatorade does you no good. I mean, you have to be profusely sweating in order to need those electrolytes. Yes. Covalent bonding is when atoms share one or more pairs of electrons. And so you can have a single, double, or triple covalent bond. Single bond, so you are sharing a pair of electrons, one pair, 2 electrons. Double covalent, you have 2 pairs or 4 electrons being shared. And then triple would be 3 pairs or 6 electrons. And there's nonpolar and polar covalent bonds. Nonpolar, well, polarity means there'd be a positive and negative end. So if it's nonpolar, the electron is being shared equally, and so the time around each is the same, and so it is equally shared. It's equal. That distribution of charge is equally spread over the whole atom or the whole molecule. Actually, it wouldn't be. Well, yeah, covalent would be a molecule. Polar covalent is when electrons do not share equally. So the one atom kind of hogs the electron from the other. It shares a little bit, but the electron would spend most of its time around one atom compared to another, and that is called polar. And so you have a slight positive and a slight negative end to that molecule. Does that make sense, the difference between polar and nonpolar, for those of you that haven't had chemistry yet? Yeah? Okay. Molecules and compounds. Sometimes you actually use the terms incorrectly because molecules are dealing with just covalently bonded compounds. So you have like hydrogen molecule there is an example of molecule. Compounds are any substance that has 2 or more different types of atoms. So it could be a covalent or ionic bond. So all molecules are compounds, but not all compounds are molecules. An example there is water. Water is a compound. It's also a molecule. it's covalently bonded together. The molecular mass is determined by adding up the atomic masses of the atoms or ions from the periodic table. So if you looked at sodium chloride, you'd look up sodium's mass is 22.9 plus chlorine's mass is 35.45. Okay, so that was all intramolecular forces, the bonding. Intermolecular forces are forces that are between two different molecules. And they occur between polar molecules because there's always a positive and a negative end. That positive negative end can be attracted, have an electrostatic attraction between that molecule and another one to kind of hold it together. It's much weaker than the chemical bonds. The chemical bonds are strongest, but it does influence a lot of structures and characteristics of different compounds. An example, and probably the most common that's in your body, is the hydrogen bond. It occurs when hydrogen does not attract electrons very strongly, so it is a lot of times a positive charge part of the molecule. Its polarity is positive. So the other part, oxygen, nitrogen, or fluorine, or whatever atom it is usually the negative part. So there's an attraction between the hydrogen and another molecule. So here is, right here would be a hydrogen bond. So this isn't actually a bond. This is one water molecule being attracted to another water molecule. And in water, this is a very important characteristic. It is what holds, based on all of its other properties, water should be a gas at room temperature. But because of the hydrogen bonding that occurs, it gets held together and is actually a liquid at room temperature. If it didn't stay a liquid at room temperature, we wouldn't have life as we know it right now. It's also why ice floats. Ice would sink because the hydrogen bonds, the way they have to, the molecules have to orient themselves, when they slow down and come to more of a standstill, they just slightly vibrate. There's little air pockets in between the molecules, which makes the ice less dense. So then ice would float. If ice sunk, like in a pond, if the ice would sink, it would make all the water come to the top, and it would freeze all the way through, and no life would be able to survive the winter in a pond. So it's a very important characteristic of water. And then that bottom dash too, it can play an important role in determining the shape of complex molecules. So some of these really long macromolecules, they actually can fold up on each other, and there's different parts of that same molecule that are positively negative, several different positive and negatives, and so they are attracted to each other, and it kind of makes that molecule fold up. Kind of like a protein. We'll look at proteins, and that's how they fold up. So this just shows the differences between the ionic, polar, nonpolar, and hydrogen bonds. Okay, these intermolecular forces are what what affect solubility and dissociation. So solubility is the ability of one substance to dissolve in another, like sugar and salt dissolve in water. So if it's soluble in water, some substances are not soluble in water. Can you think of a substance that's not soluble in water? Rock, okay. Oil, stuff that doesn't dissolve, right. I don't think rocks are they soluble in anything? Acid, maybe? Lava. Dissociation or separation of ionic compounds is when, like if salt gets put in water, it dissolves, but what's happening are the bonds are breaking, and the ionic bonds, they're being split, and there's sodium ions floating around and chlorine ions floating around. Right, it does have, you can only dissolve so much too. If it's saturated, it won't take up any more. But this is a block of salt, and so here's sodium, or chlorine and sodium ions, And because water is polar, has positive and negative ends, it kind of surrounds. So this is the positive end. The negative end of water kind of surrounds it, whereas this is a negative chloride ion and the positive hydrogens surround it. So it's called dissociation. These ionic compounds form electrolytes. In water, because there's positive and negative ions floating around, it's able to conduct electricity, and that's called an electrolyte. So electrolytes are made by cations and anions. And they are able to conduct electricity, and you are able to detect those currents with electrodes. Non-electrolytes are solutions made with molecules that dissolve in water. So it dissolves in water but do not dissociate, like sugar. Sugar is a larger molecule. It dissolves, but it does not dissociate, and so it does not conduct electricity. And then the last thing, we're going to look at reactions and even the energy of reactions and speed of reactions. So atoms, ions, and molecules or compounds interact to form or break chemical bonds. So we have reactants, which are what we start with. Products are what we end with. Chemical bonds are either made or synthesized or broken or decomposed during chemical reactions. And the sum and all the reactions that are in the body, it's called metabolism. So a synthesis reaction is we take two or more things and then chemically combine them to form a new larger product. Chemical bonds are made and energy is stored in those bonds. It's responsible for growth, maintenance, and repair. This is a dehydration bond or dehydration reaction. It's not all synthesis reactions are dehydration reactions. This is one because you basically are taking off the OH here, the hydrogen bond, the hydrogen here, and making a water molecule. So you're dehydrating these two, taking out water to form something new. Whereas decomposition, you're taking the water, splits, and helps split this big molecule. And this is called hydrolysis. Lysis means to split, and hydro means water. So you're splitting water. An example is when ATP. So ATP have these bonds that are storing energy. When those bonds break, it's releasing the energy. So the ATP is the energy molecule of the body. A lot of reactions in your body are reversible, meaning you have these reactants and they form products, but if those products can form reactants, go back and forth, and it depends on the proportions of reactants and products. And at some point, it will reach equilibrium, where the forward and backward reaction are occurring at the same rate. That's called equilibrium. And the last, talking about energy and how we lower that energy. Potential energy is stored energy. And one form that we'll look at down is chemical energy. Energy is the form of potential energy that's stored in chemical bonds. Kinetic energy is the energy of motion when you're doing work and moving matter. Mechanical energy is a form of that. It's resulting from position or movement of objects. So think about those big windmills. When those propellers are moving, that's going to create the energy. Then heat energy is energy that's flowing between objects of different temperatures. How does heat flow? Like if you touch the desk, how is the heat flowing? From hot to cold, always, yep. So it's from your hand to the desk in that case, because the desk feels cold. So this is how ATP works. It starts out as ADP, D meaning di, so we have two phosphate groups. And then once this other phosphate group forms, it has more energy now because it has three phosphates. They have an extra bond, so it's a stored energy. Then when you break that bond, you're releasing energy, and now ADP has less potential energy. And how do we speed up those reactions? Heat. Temperature is really just a measure of how fast molecules are moving. So if you're increasing the temperature, you're increasing the rate. And so they're moving faster, they're able to, a chemical reaction, these compounds have to run into each other and hit, and they have to have some sort of close proximity. So when they're moving faster, it's more likely that they're going to run into another compound that it'll react with. Concentration, if you add more reactants, it's going to react faster. And then catalysts. What do catalysts do? Speed up reactions. And the catalysts that are in our body are called enzymes. And enzymes increase the chemical reaction by lowering activation energy. There's a picture of this on the next one. But the activation energy, in order to have this chemical reaction to occur, you have to have so much energy, and then it kind of like has to reach this threshold and then comes down. Has to get up over this activation energy. So in this picture, this vertical part represents the activation energy. So it has to get up and over this part in order to have the reaction occur. What an enzyme does is it lowers that activation energy. It gives it a little loophole to get through, so it doesn't have to go up and have that much as much energy to get over that little hump of the reaction energy. So we have it lowers the activation energy. Okay, grab a clicker. Oh, the clickers are over there now. What? No. It's a fun word. Yeah. Complex idea. So, what are the subatomic particles located in the nucleus? Which one are located in the nucleus? What does yours say? It should say. It has to be you. Is it? E and everyone is correct, yes. Protons and neutrons. Atomic number is equal to, what is the atomic number? I'm still waiting on one of them. Oh, there it is. The answer is B. Yes. The protons. Protons is the atomic number. Protons plus the neutrons is the mass number. Chemical behavior of an atom is largely determined by whether or not it's going to react with something. Looking at the reactions, the bonding. Answer is E, yes. Electrons. The electrons are what are formed bonds. Remember, we're either sharing electrons or you're stealing electron away. When the outermost electrons are transferred or shared, what occurs? Oh, and on this one, the other class said, oh wait, you can see it. You don't have the notes. They had the notes. Never mind. Ignore. They printed them off. Electrons went out of it. I'm missing one. Number 3. It is D. All right, chemical bonds. Oops. Atoms that are gained or lost, or atoms that have gained or lost electrons. Someone answered 2 letters. Okay. Yes. No. Oh. 2 atoms with the same number of protons and electrons, but different numbers of neutrons. Well, I didn't show it. That's right. Everyone answered it, but maybe it's all wrong. No, you're all right.
That'd be really funny if one time you're all wrong.
When sodium and chloride and salt, table salt, separate, that process is called what? Answer is yes, D, dissociation. Good. You guys are doing good. Substances that produce ions when dissolved are referred to as they produce ions. So they produce cations and anions in solution. Oops, I keep pushing the wrong one. Someone pushed all 4. E. And that's not even one you put in. Electrolytes. So when they separate into ions, they're able to conduct electricity, and they're called electrolytes. What kind of reaction is this? Sucrose yielding glucose and fructose.
Yeah, I thought this was about muscles and whatnot. That's the only reason I took it. This is about like chemistry stuff.
Yeah, why exactly?
Chemistry of life. This is all occurring in your body.
No, it's not.
Yeah, it is.
Yeah, but that's what chemistry's for. And this should be about muscles. That's the only reason I took it, because that's what I'm thinking in college.
We'll do muscles next semester.
Are you serious?
Serious.
Oh, is that what we're doing this semester? I'm gonna have to drop this class then.
I'm not doing all chemistry, no.
I sucked at chemistry. I just didn't even
B, decomposition, because we're taking one large compound and splitting it into 2.
Everybody's changing.
No, I can't. Oh. Which of these influence the rate of reaction?
Immediately. You ever seen that movie?
Despicable Me?
No. Division 3, Phillips' Finest. Get some. Go every time so that others may. Every
Oh,
time.
I don't know. E might not be right. It's right. Yes. All the above. I think that might be the last one. Yep. Last one.